Hi guys, and welcome again to my channel, and welcome to day number 6 of the PiHut Maker Advent Calendar we've got here, and today is box number 6. So we'll get that open here. And we'll have a look and see what we've got. So in today's box, we have a photo transistor, a 10K transistor, and some more male-to-male jumper wires. Okay, so today we'll be learning how to take analog readings from our light sensor and converting those into something more useful, as well as some other new tricks to manipulate data and strings. We'll also make a light indication project with our LEDs. Sensors similar to these are used everywhere in the world around us, in street lamps, vehicles, room lighting and more. They detect the amount of light, and this determines the amount of electrical current that is passed across the legs. A great one to learn and use in many projects. We're going to use the LEDs again and also the buzzer, so leave them in place and remove everything else. Your circuit should look like this to start with. Before we start with today's circuit, we must stress that you need to pay close attention to the legs of the light sensor. If you get the wiring wrong here, your light readings won't make a lot of sense. So with that in mind, grab your mini breadboard and fit the sensor with the long leg to the left. It should look something like this. So I'm just going to get the light sensor. I'm going to put the long leg to the left and place it in the breadboard. Now we need to add 3 wires and the resistor. Connect the right short leg to the 3.3 volt pin, physical pin number 36. So right leg to pin 36. Which is there. Connect the left long leg to GPIO 26, which is physical pin 31. And 31 is 33, 32, 31. Add the resistor to connect the left leg over to another empty unused lane on your breadboard. Connect the other end of the resistor to the ground pin on your Pico. Whoops. Okay. So your circuit should look something like this. Activity 1, simple light sensing. Let's start with a simple starter program which grabs a light reading for us. This is just a minimal program to return the analog value once, which isn't all that useful to humans, but will convert it to something more practical in the next activity. In this example, we import ADC to use the ADC function. Set up the sensor GPIO pin as the ADC pin. Create a variable called light, which reads the sensor value. Print the variable value. Copy the code below over to Thonny and give it a try. So I've copied that code, paste into Thonny. Now I just need to connect the Raspberry Pi. And then let's run the script. So the light sensor is reading 62639. So activity number 2, making light readings usable. We know we can grab a single reading from the sensor with a very short program, but we really need that reading to be in a format that we can use and recognize. In the example below, we convert the reading to a percentage using a little maths. We'll show a few examples as there are some tricks we can use to make the printed values even more useful. So, for example number 1, this example takes the reading and turns it into a percentage. It divides our reading by 65535, the maximum of the analog reading range, then multiplies this by 100 to give us our percentage value. So let's copy the code for that example, paste it into Thonny, stop and start, and now we're given a reading of 96.02045. Example 2. This example builds on the previous one by limiting the number of decimal places, as we don't really need that much detail for something like a light reading. To do this, we use built-in round function in our percentage calculation. You'll see this below where we used round. This is taking the light reading, applying the same percentage calculation, and then the final number 1 defines how many decimal places to use. Try the example below, then try changing the last number to 2 or 3 to see what happens. And then try removing the comma and number altogether, which will remove the decimal. So let's copy the code for example number 2, paste it into Thonny. So we stop and start, and we're given 95.9, 1 decimal place. So let's change the 1 here to 2 to give it 2 decimal places. We'll stop and start the code again, and now we're given 2 decimal places. Let's change that to a 3. Let's stop, start it again, and now we're given 3 decimal places. So example number 3. Our final example adds the percentage symbol after the reading. We do this by adding some parts to our print line. Normally, when we print the reading, the value is a number. In our example, it's a float to be exact, and it has a decimal. However, we want to print that value along with the text at the same time with the percentage symbol. We need to convert everything to a string text. The print function will not let us mix both together. We can do this by using the built-in str function, which converts values to strings. We use str light% to convert our light value reading to a string. Then add another string next to this with the plus percentage in commas. You can see this example below. Give it a try. So let's copy the code again into Thonny, stop, and then start the Pi again. And now we can see that we've got the percentage sign here. So this is where we've converted the reading to a string using str. So we've done print str light%, which is this, and then we've added the percentage sign. Activity 3, light level LED indicators. We've covered grabbing readings and converting the values, so let's put that to work with a nice little light indication project using our LEDs. We're going to run an example where we continually check the light readings and assign our 3 LEDs to a range of readings. Red will indicate a low level light, amber for a normal, and green for high light levels. In the example below, we add the LEDs back into our code and define the pin numbers. We also define the light sensor pin before we start a while loop. The while loop grabs a reading from the sensor and converts this to a percentage like we did earlier. Then uses if statements to light a different LED depending on the percentage reading. Copy this over to Thonny, run the code, and use your phone's light camera or torch to simply turn your lights off to see if it changes the program. Okay, so let's copy the code, paste it into Thonny, stop, and now run the script. Okay, so there's a high light level at the moment because we're seeing the green LED. Now, if I cover that up, it goes to red. And now I've just released my fingers a little bit. So it's letting a little bit more light in. So it's gone amber. And then if I release again, it will go to green. Okay, so good job makers. We've learned how to use another sensor today, as well as introducing some new ways to manipulate values and strings. We're going to use this sensor again before the end of the calendar, as it's a great partner for a component hiding in one of the other boxes. So what did we learn today? We learned how to wire a light sensor circuit, learned how to manipulate data to make it more useful to us and our programs, learned how to convert values to strings with the str function, learned how to use the round function to limit decimal places, and learned how to combine multiple strings to prints. That's day 6 complete, and I'll see you again tomorrow for day number 7.